we're going to be finding all the zeros. But I'm calling them zeros instead of roots today because we are going to have some imaginary numbers. Okay? But it's going to be all kind of the same procedure we did yesterday. So before we do that, we're going to learn something about Descartes. He's a mathematician who came up with this rule of signs that allows you to find out how many positive x-intercepts or roots, how many negative x-intercepts, and how many imaginary you could have by just looking at the function. So this would be something you do without a calculator. So if you have a class where you were not allowed to use a calculator, you could do it this way. We're just learning the procedure. We're not going to really use it that much. We're just going to do it, okay? So what you're going to do first is we're going to find the positive roots. Possible. This is possible. This is not for sure the number. You're going to look at your function, and you're going to look at any place where it changes to positive to negative or negative to positive. So we're going to start with, is that positive or negative number? And then we go to a, so this is a sign change. That's the first one. Then we've got a negative sign, and then we have a positive sign. So that is a second sign change. And then we have a positive sign to a negative. That is the third sign change. And then we have a negative to a negative, not a sign change. Negative to a negative, not a sign change. Negative to negative, not a sign change. So we have 3. That tells us there are 3 possible. This is the maximum amount. 3 possible positive roots or x-intercepts for this graph. Means if I were to graph it, the most x-intercepts that would be on the right side of the graph would be 3. The most. It means there could be less than 3. But I know there won't be 4. There won't be 6. How many total roots, how many total zeros could we have for this question? 6. So 3 of them could be positive. To find the negative, we're going to kind of do the same thing again, but you're first going to input negative x for every single x. You're going to change every single x to negative x, and then you're going to do your exponent. So when I take negative x and I take it to the 6th power, what happens in the negative sign? It becomes positive. So I have x to the 6th. Then I do negative x to the 5th, which is a negative number, and we multiply that with the negative 2 in front. We get a positive 2x to the 5th. The next one, I input negative x to the 4th. That's positive. So we still have 3x to the 4th. The next one, negative x to the 3rd, is negative, and multiply that with the negative 10 out front. We get positive 10x to the 3rd. Then we've got negative 6 times a positive number, so it's still negative 6x squared. Then we have negative 8 and negative x, so that's positive 8x. And then the negative 8 at the end doesn't change because there's no x's. And we look for sign changes. So we've got positive, 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 negative. So here is one sign change. Then we go to positive. There's another sign change. And we go to negative. There is a third sign change. So maximum, how many negative zeros? 3 negative zeros, or roots. Now that is the maximum. There could be less. So what we're going to do is we're going to organize all the zeros in a chart. I will have so many that I will go out of a chart, just so you know. I didn't make the chart big enough. So we're going to think this through. What was our maximum amount of positive zeros we could have? Correct. What was our maximum amount of negative zeros we could have? And total, how many zeros could we have? 6. So if I have 3 of them being positive and 3 of them being negative, how many of them are going to be imaginary to get a total of 6? There will be 0 imaginary if I have 3 and 30. Side note, what is an imaginary number? What is it? Square root of negative 1. That's what the imaginary number is, the square root of negative 1. And since it is involved with a radical, we learned last week that if you have a radical root, you actually have conjugates. They come in pairs always. They always come in conjugates. So if you have a radical, you have two. You will never have a single radical root. So imaginary zeros are always in pairs, which we call conjugates. That means in my chart, anything that I write in the imaginary column has to be even. I cannot write one imaginary number. There will be at least two if there's any. So, because 3 is the highest amount of positive, what if we only had 2 positive numbers? How many negative numbers could I have? Okay, so here's our thought. If we said, well, I could have 3, and 2 plus 3 is 5, that means I have 1 imaginary. But that's not possible. So I can't have 2 and 3. But I can have 2 and 2. And that would give me how many imaginary? Okay, somebody else said I could have 2 and 4. But that's not true. Why? Because the max is 3, so I can't have a 4 in the negative. Could I have 1 and 1? How many imaginary would I have? And is that okay? Could I have 1 and 2? No, because I cannot have 3 imaginary. What else could I have? What could I have? So I could have 0, 0, and 6, yeah. Sorry. Can I have what?
0, 3, 3.
Can I have 3 in this column?
No.
So no. Could I have 0, 2, and 4? Could I have 2, 0, and 4? There's another one. Yes. 1, 3, and 2, 4, 3, 1, and 2. Okay. So today, you are going to first make a table to show all the different possibilities. All right? So if you were doing this by hand, this table would be important if you didn't have a calculator to help you. But since you have a calculator to help you, you are going to be able to find out how many there are in your calculator. So you're still going to practice this table for today. Go ahead and turn the page. We're not going to finish finding anything for that one. We're just going to go to the next question. I changed the equation. Since I printed them out, I changed the equation. I made this one, but then this one was way too hard. So we're going to change it. We're going to do one. X cubed minus 1 instead. Okay. So what we're going to do first is we're going to look for sign changes and find the possible positive, negative, and imaginary zeros first. So let's do positives. Are there any sign changes? This one's positive, this one's negative, 1 sign change, right? So the maximum amount of positives is 1. When we go to find the negative, you have to plug in negative x into the equation. And when I take negative x to the 3rd power, I get negative or positive? Negative x cubed minus 1. Is there a sign change? No, there are 0 negatives. So we make a table. Positive, negative, imaginary. How many positive? What is the maximum amount of positives? 1. What's the maximum amount of negatives? 0. And what is our degree? 3. So how many imaginaries would we need to have? 2. Okay. Can I have 0 positives and 0 negatives? Why not?
Because otherwise that would be 3.
Right, we can't have 3 here. Can I have 0 and 1?
No.
Why not?
Because that exceeds the maximum.
Because maximum is 0 for negatives. So I don't have any other possibilities. Like, this is it. This is what we're going to have. So now, how are we going to find the zeros? What's our first step? What do you remember? Yes, sir. What do we do? Okay, let's list all of our P's and Q's. What's our P? What's our Q? What are our possible P's and Q's? Plus minus 1. All right, we got 2 of them. Now what should we do? Go to your calculator. All right, so go to your calculator and type it out. I'm not going to have you require you to list all the P's and Q's first time. But you can if you really want to. I wanted you to do it for an assignment so you know how to do it, and you're going to do it on the clip. But you don't have to do it for that. Go ahead and graph it. It is a nice graph, isn't it? Now, do you think you know what the 0 might be? Okay, so you think maybe looking at it as 1. If you hit second, can I borrow somebody's calculator that has a color? So it shows up. Just so I have it under here. So if I, instead of doing like the 0 thing, instead of doing second trace 0, since I think it's at 1, I'm just going to do value and say, what is y when x is 1? Oh, it is 0. So if I think it's 1, I'm just going to do my value. Again, I did second trace value, and then I chose 1. I think it's at 1. And then it tells me, yep, that's a 0. So that could be a little shortcut if you think you know where it is. Otherwise, you can just do second trace 0, left bound, right bound, guess. That works too. So we think it's at 1. It looks like it's at 1. Let's do what with the 1? Can we use synthetic division if it's 1? Yes. Oh. I thought you were thinking. All right. When I do synthetic division, what am I going to put as my coefficients? Sorry. 1, and then how many zeros? 0, 0, then 3 to 1. So we did our synthetic division, and yes, 1 is a 0. And then we have left over a quadratic. We're down to 2 powers. So we can write x squared plus x plus 1. What do we know about the answers to this? According to that chart we made, what do we know about the answers? There's 2 imaginary answers. So you could maybe factor it, but you're going to have an imaginary answer, so probably not. Or you could use quadratic formula, so let's do that. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Do you know the song yet? So I get -1 plus or minus square root -3, which is what I was expecting to give, over 2. And to simplify the square root of -3, we factor that down to the square root of -1 and the square root of +3. And what is the square root of -1? I. So now we have x equals -1 plus or minus I radical 3 over 2. You'll notice in the directions and also in the assignment today, it just says find all the zeros. So I'm not even asking you to put it in factor form. I'm just asking you to find all the zeros. So what was our first 0? 1, and then our other 2 zeros are -1 plus or minus I root 3 over 2. So that would be our answer. So we're using what we learned last class and applying it to the same stuff, just now we might have imaginary answers. One more? One more. Okay, so you do the sign change thing. Let's see if you can figure out the positive and negative roots and then imaginary from that. You do the sign change. So where's the table? Okay, positives. How many sign changes in the original question? Here. And then we change the question, we plug in negative x. But when I plug in a negative, and then I take it to an even power, it's still positive. So how many sign changes for negative? So we definitely have 0, 0. How many imaginary? Can we have a different number for positive or negative? Because 0 is a maximum. It can't be -1. Okay? So I know for sure that this has 4 imaginary answers. So what would happen if I graph it? Did anybody graph it yet? Did you graph it? It looks like this, right? Y-intercept is, it like hits the graph at 5 and it's like, because it has no real x-intercepts. It only has zeros. It does have numbers that make the equation equal to 0, but they're not real numbers, so they won't show up on the graph. So we've got to have another way to find these answers that does not involve synthetic division. So there is another way, and I've only given you questions that you can find answers for. So we look at this and we imagine this, instead of like x to the 4th, you think about that just being quadratic, instead of x to the 4th, you think about it being quadratic. I don't know, if x to the 4th was something like y squared instead, then this would be like 6y, and this would be like 5. So that's factorable. Can you see how it factors when it's the y's? How's it going to factor if it's I'm going to have x squared plus 1, x squared plus 5. It's factorable. Right? If I FOIL that back together, I get x to the 4th, I get 5x squared, 1x squared, and 5. So it is factorable. So if I give you one that only has imaginary, check factoring. And then from here, we're going to set each factor equal to 0. So I'm going to have x squared plus 1 equals 0, and I'm going to have x squared plus 5 equals 0. And you can solve x squared plus 1 equals 0. How? Subtract the 1. Square root, but what do you have to do if you square root? Plus minus, square root, -1. What is the square root of -1? So we have x equals plus minus I. That's 2 imaginary answers. How do we solve this one? Subtract your 5, square root, plus minus, and then simplify square root -5. So we get x equals plus minus I radical 5. Good. So our 4 zeros are plus minus I, plus minus I radical 5. So that means if I plug in I into the original question, I should get 0. If I plug in -I into the original question, it will equal 0. Even though I is imaginary, you can't see it on the graph, it still equals 0, so it is called a 0. All right? There is a typo on your homework, sorry. There's a typo on your homework. It's number 1. This is what happens when I type things myself. It's number 1. It should have a plus 12 at the very end. Please change that before you start. You can work on that new homework, or if you still have questions on the old homework, we've got, like 13 minutes left. So please ask. Either work on tonight's homework or ask about yesterday's. I'm going to come around and make sure everybody's got the plus 12.